Hi guys, Mr. John here. In this video I'm gonna take a look inside of this AN8008 multimeter that I purchased off Banggood and see what's inside. I do know what's inside because I saw multiple videos about what's inside these multimeters, so I kinda know what I do know what to expect, but still a bit interesting to see. Maybe they changed something, maybe my meter is a bit different, later revision or earlier revision. This has nothing to do with it. First, my impressions: I do own this meter for just a couple of days, but I straight away kinda like it for its size. It is so compact. It makes a nice pocket multimeter. They don't really say that it's a pocket multimeter, but come on. It completely fits on the palm of a hand, so it is not much. Well, it is actually the same outline size as my phone that I'm filming is right now. It is only much thicker, but long and wide is about the same. Now, how do I take it? I probably need to take this off as well. How do I take it apart? Oh, yo. Here we go. Yeah. Just what I expected. Nothing changed. We do have a sneaky switch there. I might actually check out what it does. The beeper is a bit annoying actually. I do not like that it just goes and beeps every time you change the range. It's kinda annoying. Yeah, the fuses are minuscule. We do have a couple of MELF packages. Nice. The fuses are ridiculous indeed. Pesky little devices. I mean, like, Jesus Christ. They are ceramic, not a glass ones. And to compare it to the regular size fuse, which the Unity UT56 that I own uses. You can see the comparison. Yeah, quite crikey. Here we have the reference, ICL 8069. .8 volt Zener diode, I reckon. There. Says it's a Rubicon. I don't know whether it is or not. Not too bad. Very minimalistic protection, but oh well. Okay. It's much louder without the case, obviously. But even in the case it is quite annoying. So let me go and short that switch out and see what happens. I hope it won't do anything stupid, like reset the firmware or what, or calibration. How do I do this? Mm. Oh, that switch doesn't seem to do anything. Yes, that switch does not do anything. Too bad. I was kinda hoping that it may be some hidden feature. Nope. Oh well. We do have these split tubes, so they might get loose, but oh, not too big of a deal. They're not. They're nice and tight at the moment, so I'm not too bothered by it. Soldering looks fine. A little bit of flux residue on this, and that's that. Now let me put it back together and compare the readings with my other meters. Many people also have trouble with self-tappers. I own my UT56 for quite a while, and it also uses self-tappers, and I changed the fuse in it multiple times because I bought it when I was not really that experienced. And the trick with self-tappers is to put it in there. It's a bit stubborn, but you put it there, right? And do not just go and twist it in. You try to align it, then you turn it counterclockwise, screwing it out until you hear a click. There we go. Now it turns it in, and you can do that multiple times without hurting the plastic. It's not a rocket science, people. Just basic understanding of these ridiculous simple things. Okay, I don't need to tell what was it, what is what, because you can see it. Notice that this meter does have a little bit of offset. It's not connected at the moment, but it does have an offset. Yay. Very professional job there. Alright, now I'm gonna connect my power supply to it. All meters are in parallel, of course. Switch, that's funny. It's on AC. You muppet. You freaking muppet. There we go. Not too bad. Basically, they are reading the same. This one is a bit off, but this meter has seen some better days. Okay, now let's You can see that Unity by far is the best here, because it has the most decimal places. On this range the A9 goes to 10 millivolts. This bastard goes to 1 millivolt. But it's a 20,000 count meter actually. I don't know why I thought that it is a 2000 count, it's silly. $484. See? 4835, 4835. Freaking awesome. It agrees. Look at that. Digit to digit. That's fantastic. This one is not. These two are not as not as bad as well. 2338 again. 338, 34. Fine actually. I am impressed by these two. They are quite not as shoddy as I thought they are. Let's actually put it on the low voltage and switch the ranges. Right now it's a 20 volt range, and it displays down to 1 millivolt. And this meter right now is on 10 volt range and it displays down to 1 millivolt, so that's quite good. But if I'm gonna switch it to 2 volt more range, you can see it displays 200 microvolts. Insanity. Okay, 6 to 7, 6 to 8, 6 to 9, and 6 to 9. Not too bad. I'm fine with that. Okay, next low current stuff. Gonna apply 10 volts. I'm gonna use 10 mega ohm resistor. And I'm gonna omit this from the circuit because this bastard came to me faulty. I purchased it and it was faulty. The milliamp range did not work because one of the shunt resistors, namely 901, is just open for whatever reason. Let's set it to about 10 volts. Close enough. Considering I use a single turn potentiometer on a power supply, it's not too bad. Okay, all meters now are connected in series because we are measuring current. We're gonna put them on the lowest range they can offer. Annoying little bitch that beeps all the time. It would have been excellent if not for that beeper. Okay, power supply. Where is it? Again, notice that these two are nulled out perfectly. This one it has an offset of 2 microamps, so we're gonna take that in mind. We see 1 microamp on the Unity, 1.1 microamp on the A9, and 3 microamps on the M890. But again, this one has offset of 2, so we are basically reading the same thing. 10, 10, 10. Fine. Now let's bump the current a little bit. I do have a few resistors that I purchased. These claim to be a 0.1% resistors, and I'm now gonna use 10k resistor on it and see what it has to say. Try to not introduce any leakage current. Okay, 970 microamps, same. This one is a bit off, but that's fine. quite nice. I don't mind that. Yeah, that's fine. Let's up the current a little bit. But now we should switch ranges, really. Oh, let's try 100k resistor first. Here about 100 microamps, 99.8, and about 102 there, so yeah, it's 100 microamps. I'm impressed with this bastard, here to say. I thought it might be a bit more out, considering that it has this offset which you can remember and null out in your head. It's not too bad at all. Now let's check those resistors. I don't have any capacitor to use as a reference, really. Okay, let's start with 10 ohm resistor. Let's start with the AN, but have in mind that the probes on this meter are get it close. About 100 milliohms. So we should see about 10.1 ohm. Yep. That's what we are seeing. Next. Unity. Again, this one has a bit more horrific probes. 0.3. Take that into account. Yep. And the Frankenstein. Again, the same. It would help if I would plug this in into right. This one by far is has the shittiest probes, which are 2 ohms. That's ridiculous. Although it might not be 2 ohms, it might be that offset again. Remember, it was 2 on each and every range. So we should see about 12. And certainly we do see just that. Next, 100 ohm resistor. Hey. Oh, it's a 1k resistor. Oh, what a... this stupid 4-digit designator. 1000. Nice. Nothing bad to say about that. $1005. It's goddamn almost 10 p.m. and they still interrupt me. What a beautiful life I live. 100, let's say 005. Let's see what the Unity has to say. Ah, crap. It's getting really annoying. Will you take a look at that? I mean, like, oh, get back there. Get back there, you muppet. 0.9999. You were... whatever. So what is that? Ran out of memory as always. So this meter basically says it is 0.1 ohm out, 0.2. The AN... crap, so many probes. The AN says it is about 5 ohms out. About 3 or 2. 2 ohms out, but in a different direction. So anyway, now 10k resistor. $10.02, let's say $10.03. Hey, 9995. What was the yeah, this reads a bit higher, but I don't know which one is closer to the truth. That's a funny thing about it. This one is surprising me a lot. For what it is quite nice. So that's that really. I can't really do any more elaborate testing. First of all, this video is already much longer than it has to be, and let's make a beeper test. And very fast response, most likely because it is processed by a simple comparator, not by a chip like it is here. No delays, no turn on delay, no turn off delay. And then it would help to put it in the right range, of course. No turn on delay, but there is turn off delay. As for this one sounds a bit sick, like it has a sore throat. Okay. Got interrupted again as always. Again, this one I guess this function is taken by a comparator, so it is pretty much no delay. Very fast. That's why I use it for continuity. This for amps, that one for volts. As for this one, for a combination, I really do like the frequency counter on it, because this meter would have been fantastic. But take a look at this. I mean, like, really? 20 kilohertz upper limit? Give me a break. This one can measure up to 10 meg. It actually can measure far beyond that, but it loses sensitivity quite a lot. It can measure 200 megahertz. Let me tell you what. But it requires like 10 volts RMS RF into it, which is a lot. There is no way I would be able to test the that kind of frequency, to measure that kind of frequency, which I will take off the simple one transistor oscillator or anything like that. Another feature that bugs me a lot about this meter, so that I can keep it on the necessary range and just live my happy life. But this one, Oh, why? Why is it so popular today to use the off position on a rotary switch? Come on! Put the switch like that. Why did they stop putting these kind of switches there? I don't get it. Conclusion. This meter is perfectly accurate for me. I do like its size. It's very small. It's pocket-sized multimeter, if you ask me. The pouch, well, it does not stink, as one YouTuber said. One YouTuber said it reeks. I wouldn't say it reeks. It just has a bit of plasticky smell to it, but that's fine. So you got just go do this, like that. Wrap the probes around. Of course I'm gonna fail miserably on camera to do this simple task. Put it in there. Move the probes to one side. And you're good to go. It easily fits in a pocket. Even if it's not in a pocket, you can just put it in a small bag and measure stuff far away from the bench. That's the beauty of this meter. Okay. The next videos are gonna be about the power supply, which you see there. I did buy a replacement capacitor for it, this one, to be put instead of that one. That one is quite tall, as you can see. This one is fat and short. It will fit just fine in the enclosure standing up. Thus I will save space on the board, because if I would have used this one, I would have been forced to lay it down. That way it would eat a lot of space on the board. So that's it. Thanks for watching. See you.